Hello and welcome. In this part, we're going to look at the derivatives of the trig functions. So let's get started. First, we have the derivatives of sine and cosine. And you might notice right away that the derivative of sine is cosine, and the derivative of cosine is negative sine. And you probably noticed that because it's right there on the page. All right. So the thing that you notice here is that sine and cosine, the derivatives go back and forth between each other. So if you keep taking derivatives of sine, like if you took the derivative of the derivative, then the derivative of the derivative of the derivative, you just go back and forth between sine and cosine. The only difference is that this negative sign appears when you take the derivative of cosine. You get this extra negative. So that's good to know, that sine and cosine are kind of paired together in that way through derivatives. Now, one thing I want to point out is that all of the trig functions that start with c, so right here cosine starts with a c, and cotangent starts with a c, and cosecant starts with a c. All of those trig functions that start with a c happen to have negative derivatives. So you have the derivative of cosine is negative sine, the derivative of cotangent is negative cosecant squared, and the derivative of cosecant is negative cosecant cotangent. That's just a little mnemonic to help you remember that which trig functions have negative derivatives. It's just all the trig functions that start with a c. Now you might be wondering how you're going to remember the derivative of tangent and the derivative of secant. You know, how do you get secant squared and secant x tangent x? Well, here's a little mnemonic to help you out. So suppose that you're on a Calculus 1 test and you forget the derivative of tangent. So you turn to your friend and you go, "Psst, what's the derivative of tangent?" Your friend looks at you and says, "Dude, I'm taking a test." No. So in that question, "Psst, what's the derivative of tangent?" is actually the answer to the derivative of tangent. That's why we listed it right here. So let's take psst and write it out. And we'll ignore the p because, I don't know, the p is always silent, even though it's not here. And we'll just focus on the SST. So S is going to stand for secant x. Same for this S. And then T stands for tangent. So the way this mnemonic works is if you want to know the derivative of, let's say, secant, you can read it left to right. The derivative of secant is secant x times tangent x. And here it is. The derivative of secant is secant x times tangent x. Then, to answer your own question, what's the derivative of tangent, you can read it backwards. So the derivative of tangent x is secant x times secant x, which is secant squared x. So just a quick little mnemonic that can help you remember the derivatives of tangent x and secant x. Now for cotangent x and cosecant x, it's basically the same idea. Instead of secant, we're going to write cosecant. Instead of tangent, we'll write cotangent. And then we'll put a little negative in the middle because the derivatives of the c functions have that negative. So that just makes sure to get the signs working properly. So then if you want the derivative of cosecant, it's going to be negative cosecant x, cotangent x. Then if you want the derivative of cotangent x, it's going to be negative cosecant times cosecant, which you can write negative cosecant squared x. So these 6 trig derivatives are not too bad to remember. Just remember the derivatives of the c functions, trig functions, are all negative, and then you can remember the psst mnemonic, and you should be good to go. So with that said, let's jump over to the notes and try example 4. So here we're looking at the derivative of 2 cosine x minus secant x plus 3 cotangent x. So what we could do is we could take this step by step, and use the constant multiple rule, the sum and the difference rules to break this complicated derivative of a complicated function down into derivatives of smaller functions. But we're going to take those two rules for granted and just know that the derivative will work its way into the cosine x through those rules, and it'll work its way into the secant x through those rules, and into the cotangent x. I mean, after all, that's what it did to the other examples where we had different terms and coefficients in front of those terms. The derivative can work its way through those two rules into those smaller functions. So when it does, we're just going to have the derivative of cosine x right here. The 2 was a constant multiple that just got pulled out, and we just are focusing on the derivative of cosine x, which is negative sine x. Derivative of a c function is negative, and cosine and sine just go back and forth between each other. Then we have minus. What's the derivative of secant x? Secant x tangent x by the mnemonic. Then we have plus 3 times the derivative of cotangent x. And the derivative of cotangent x we know is negative because it starts with a c. Cosecant squared x by the same mnemonic. Now the only thing left to do is maybe clean this up a little bit. So negative 2 sine x minus secant x tangent x minus 3 cosecant squared x. And there's the derivative of that function. All right, thank you for watching, and we'll see you in the next part.